Hello, I'm Takashi Oya. My username is Mamas in Kaggle. I'll introduce the second place solution for Riiid answer correctness prediction. This is the agenda of my presentation. Okay, first I'll introduce myself. I'm a master student at Waseda University. My research area is audiovisual learning, especially audiovisual sound source separation and sound source localization, which is studied in the computer vision area. But because I also love tabular data and feature engineering, my past competitions are not related to computer vision. Especially, I'm good at handling very big data, more than 100 million rows. This is the summary of my solution. I call my method LSTM-SAKT, as the base of my method is like SAKT, self-attention model for knowledge tracing. However, my method is different from SAKT in many ways. The special characteristics of my method can be categorized into 3 points. First, I use LSTM to make query key value of SAKT. Second, to avoid the possible leakage problem, I used very precise indexing and masking techniques. Third, to overcome the limitation of transformer, I made additional handcrafted features. For the ensemble, I did weighted average of 6 similar models, but the ensemble is not so important in my solution. My single model takes 30 hours for training using 4 Tesla V100. Okay, then I will explain the special characteristics of my method. As I said, it can be categorized into 3 points. The first point is LSTM. In SAKT, the information of query, key, and value of transformer is very limited. For example, as the query, key, and value of SAKT doesn't have the information of previous samples, SAKT cannot consider patterns like these students tend to make mistakes after doing something. So I used LSTM to make query, key, and value to catch such patterns. The second point is indexing and masking techniques to avoid data leakage. In this competition, there is a column named Task Container ID. This column means questions are sometimes served together as shown in the image. In this case, the user must answer these 4 questions in a row and cannot see the answer for any of them. So when making a neural net model, we cannot use the information of the sample which shares the same task container ID. I call this problem inter-container leakage problem. To avoid this problem, we used very precise indexing and masking techniques. The third point is additional handcrafted features to overcome the limitation of transformer. As you all know, transformer cannot consider the information of the samples older than the sequence length. So I made 90 additional handcrafted features that contain such information. For example, the percentage the user answers the question correctly in the past. Such additional features improve the score from 0.001 to 0.002. Next, I will explain what features I used for the input of transformer and additional features. As input, I made 3 types of features: query features, memory features, and additional handcrafted features. Query features and memory features are used as the input of transformer, while additional handcrafted features are concatenated with the output of the transformer. Okay, I'll explain about the query features. Query features are made by concatenating these features. For example, content ID is mapped to 512 dimensions vector by using embedding layer. And parts tags correct answer is simply one hot encoded. The important thing is I used normalized absolute position and did not use positional encoding, as it's sufficient. Next, I will explain about memory features. Unlike query features, memory features are available after user answer question. I made memory features by concatenating explanation, correctness, user answer, and normalize the elapsed time. Next, I will explain about my handcrafted features. I made 90 additional handcrafted features, and I will explain only some of them. For example, I made how many lectures the user saw for each part, tag, and type of, because my transformer model doesn't use lecture information as input. These 90 features are concatenated with the output of the transformer and not used as the input of transformer. Okay, I will explain my transformer model. The overall architecture is as follows. First, let's focus on the fancy indexing used after applying LSTM, which is used to avoid intercontainer leakage problem. For example, in the case 1, task container ID is unique and no questions are served together. So the output of the fancy indexing is shifted version of the input. However, in the case 2, task container ID is not unique and the output is not simply shifted version of the input to avoid the leakage problem. In the case 2, for example, the fourth element of the output is not the third element of the input, as the fourth and the third input share the same task container ID. Okay, then let's look at the masking techniques used in transformer encoder. When using transformer, I used a modified upper triangular mask different from the Saint paper. Because of the task container ID, a simple triangular mask causes leakage problem. For example, the first element cannot use any information, as the first row of the mask is all ones. The second element cannot use any information, same as the first element. The third element can use the first and the second element, as the first and the second element of the third rows of the mask are zeros. In the same way, the fourth element can use the first and the second element. The fifth element can use the first and the second and the third and the fourth element, as can be seen from the fifth row of the mask. Next, I will explain some findings and tips I noticed in this competition. For the implementation, concatenating embeddings is much better than adding embeddings, which is performed in the Saint paper. This is mentioned by many teams. We also found that simply normalizing time delta is better than digitizing time delta, which is performed in the Saint paper. I suppose digitizing time delta probably leads to information loss. I also found some tricky features done by SVD didn't improve the score of the neural nets, while it improved the score of the gradient-boosted trees. In my opinion, the information of such tricky features is already contained in transformer, and they are not needed. Finally, I will explain how to make my model simpler and easier to use. The best way to make my model simple is not using additional features. Though the improvement by additional features is small, more than 80% of the codes are about such additional features. Moreover, the implementation of such additional features is very difficult, especially in time series API used in this competition. I think using my transformer model without the additional input is enough. Another trick to make my model simple is to delete some features of transformer. Especially, I think content type ID delta, task container ID delta, correct answer, and user answer gives only a very slight improvement, and they can be deleted. Thank you for listening to my presentation. I hope the insights obtained in my solution help the experts and the community of the AI education. Thank you.